So in today's video, we are going to be taking a very common derivative that you will see in Calculus 1, and that is the derivative of x to the power of x. So our f of x will be x to the x, and there are two different ways that you can take this derivative that I'd like to teach you, and one of them is going to involve implicit differentiation, while the other one is going to be using chain rule. So you can rewrite this in two ways. You can either rewrite this as a function of x, y is equal to x to the x, and then take the derivative of it using implicit differentiation, or you can rewrite it using some logarithm rules. So the first example that I'm going to give is going to be using implicit differentiation, and that is we are going to start out by saying y is equal to x to the x. So essentially what we want to do here is we want to drop that exponent over here so that it's down here out in front instead of an exponent. So what we're going to do is take the natural log of both sides. So we will take ln of y is equal to x times ln of x. And we can do that because basically one of the logarithm properties says that whenever it is that you have an exponent and you take the logarithm, you can drag that exponent down in front and multiply it. So we have ln of y is equal to x times ln of x, and what we want to do next is we want to differentiate both sides with respect to x. So we're going to take d by dx of ln of y, and then d by dx of x times ln of x. Now we've already taken the derivative of ln of y several times, and that is we want to use the chain rule because it's a y trapped within a ln of x function. So we will have our f, which is our outer function, which is ln of x. G is going to be our inner function, that is y. F prime of x is going to be the derivative of our outer function, which is 1 over x. And our g prime, which is the derivative of our inner function, and that is dy by dx, or y prime if you prefer. So what we're going to do here is we're going to use the chain rule, f prime composed of g times g prime. So this will be 1 over y multiplied by dy by dx. So this will be 1 over y times dy by dx. So that is essentially what this side of the equation is going to look like. So this becomes 1 over y times dy by dx, which we will eventually be solving for. And then we want to take the derivative of x times ln of x on the other side. And where's my eraser? We want to take the derivative of x times ln of x on the other side, so we are going to use the product rule in order to take that derivative because it is a product of two functions, namely a product between x and ln of x. So what we're going to do is we're going to set up our f and our g, where since it's a product rule, it doesn't really matter which is your f and which is your g. So f prime and g prime. So one of the functions is x and the other one is ln of x. And if you haven't already learned how to use the product rule, I have a video up which I had released a couple of videos ago where it's explaining essentially how to use the product rule. So one of our functions is x, one of them is ln of x. It doesn't really matter which is f and which is g because it's being added anyway. So f of x will be x, g of x will be ln of x, f prime will be the derivative of x, which is just 1, and g prime will be the derivative of g, which is just 1 over x. So what we can do now is we can essentially multiply this out, f prime times g, and then add on f times g prime. That's essentially what the product rule tells you to do. So f prime times g is going to be 1 times ln of x, and then we will add on x times 1 over x times 1 over x. You see that these x's are going to cancel each other out. So all we've got over here is this becomes ln of x, and this part becomes 1. So the derivative of x ln of x using the product rule is ln of x plus 1. So let's go ahead and erase that. And this is essentially what the other side of our equality is going to look like, because this is the derivative of x times ln of x. So ln of x plus 1. So 1 over y times dy by dx is equal to ln of x plus 1. So what we want to do now is we want to isolate for dy by dx. So what we'll do is we'll multiply both sides by y. So we'll multiply this by y, we'll multiply this entire expression by y. So what we've got left is dy by dx is equal to y times ln of x plus 1. dy by dx is equal to y times ln of x plus 1. However, as we had mentioned at the beginning of the video, y is also equal to x to the x, so we can substitute that back into our original expression. So dy by dx, using implicit differentiation, is y substituted in x to the x times ln of x plus 1. If you'd like to go ahead and distribute this, this is going to be x to the x ln of x plus x to the x. Either of these answers are correct. One of them is just distributed. And in the next video I'll be taking the derivative of this same function using a slightly different technique using logarithm properties.